Okay, this is your observed frequency. So you have 24, 30, 31, 11, and 4. So that's mean, okay, let's say we have, okay, so katakan, okay, kita letak O1 lah, O2, O3, O4, O5. Okay, you have 5 observed frequencies. So that's mean your K in here is equals to 5. 5 categories, Okay, so based on this 100 observation, is a Poisson distribution with a mean of 1.5 is an appropriate model. So perform at alpha 0.05. You want to test at alpha, significant levels alpha is 0.05. Okay, so this one you have your total is 100 observation. Okay, if you total up 24 plus 30, 31, 11, 4, that one will become 100. So again, you want to test whether this one is a Poisson distribution with mean 1.5. The parameter is already given. Your lambda here is 1.5. Okay, we just look at part A. So that's mean here, H0. Okay, H0 X Poisson lambda 1.5. Alternative, you want to check whether X does not follow Poisson distribution with parameter 1.5. Okay, in this case, your parameter 1.5 is given, so there is no parameter to be estimated because your lambda here is already given. Okay, so H0, X does follow Poisson distribution with mean 1.5. Your alternative, X does not follow a Poisson distribution with mean 1.5. Your lambda is given, so that means there is no parameter to be estimated. So P is equals to 0. So Poisson distribution probability function. Okay, your OI just now. Okay, we put in terms of your table. Okay, you need to find what is your probability. Okay, because the probability is not given. Okay, probability, because you need to find what is your EI. EI is, the formula is N times your probability. Your observed frequency is 100 times your probability. So now, okay, we check how you want to find the probability of Poisson distribution. So go back to the basic of finding the probability. Okay, you need to find probability X equals to 0, X equals to 1, 2, 3, and the last one, you have X equals to 4, and then we need the total up probability should equals to 1. Okay, so that's mean in this case, we already know X Poisson 1.5. Okay, refer to your stats table. Okay, refer to your stats table. So you need to find your lambda is 1.5. Okay, in Poisson. So refer to cumulative Poisson probabilities, lambda equals to 1.5. Okay, lambda equals to 1.5 on page 25, in your stats table. Okay, you want to find probability X equals to 0. So that's mean again, this one is your cumulative. So this one you will have, okay, 0.2231. Okay, if you don't want to use your stats table, you need to substitute in the formula for your probability function, which is exponential negative lambda to the power x divided by x factorial. So maksudnya gantikanlah probability x equals to 0, exponential negative 1.5, 1.5 to the power 0, 0 factorial, and so on. And then you solve probability x equals to 1, x equals to 2, up to probability x, the last value lah, x equals to 4. Okay, if you want to use your stats table, so remember this one is your cumulative. Find your lambda 1.5. So that's mean you want to find exactly 1. So probability x less than equals to 1 minus probability x less than or equals to 0. So you will have 0.5578 minus 0.2231. Okay, we get the value. So let's say you have 0.5578 minus 0.2231. So 0.3347. And then proceed. Probability x equals to 2. Yeah, cumulative. So x less than equals to 2 minus probability x less than or equals to 1. So x less than equals to 2. Okay, you have 0.8088 minus 5578. So you have the probability. So you have 0.251. And then we compute 0. Okay, probability x equals to 3. Okay, sampailah kamu dapat last kali ya. X less than equals to 3 minus x less than equals to 2. So you will have 0.9344 minus 0.8088. Okay, so you have 0.9344. So we have 0.1256. Okay, last value, probability. Okay, so you have 1 minus probability. Sorry. So kita dah dapatkan dia punya ni probability x equals to 4 Probability x equals to 4. So in this case, we will have 1 minus probability less than equals to 3. So 1 minus 0.9344. So 0.0656. Okay, you total up. Okay. Okay. So in this case, your total probability must equals to 1. So if we total up probability x equals to 0, x equals to 1, x equals to 2, x equals to 3, and then probability x greater than equals to 4, the last value should equal up, total up should equals to 1. So that's why for the last value probability, okay, even though we just write this one, okay, this one 4, that means the last value you need to total out 1 minus, yeah, 1 minus, okay, so 1 minus 0.9344, which is probability x less than or equals to 3. So you will have 0.0656. Okay, so this is how we find the probability. Okay, because the probability is not given, different from the previous example. Okay, so just okay, kita copy back. Okay, probability x equal to 0. You have here is 0.2231. Okay, the next one 0.3347. Okay, this one 0.251. Okay, ini 0.1256. And then you have 0.0656. Okay, for this one 0.0656. Okay, for EI, n times your probability. So that's mean 100 times 0.2231. 100 times 0.3347. So you will get the value. Okay, 22.31, 33.47, 25.1, 12.55, 6.57. So you check. All your EI is greater or equals to 5. EI kamu. Small greater than equals to 5. So you proceed by compute the chi-square test. Okay. So now you already have your observe, you already have your probability, and then you already have your expected frequency, the formula n times your probability, total 100 times your probability. Okay, all your EI is greater or equals to 5. Okay. Okay, so now, again, your data tadi. So conduct your test statistic, your chi-square test, summation OI minus EI square over EI. Okay. Mas ini kita dah simplify, we already compute which is 3.0714. You only reject if your chi-square test greater than chi-square alpha. Okay, K minus P minus 1. P is 0. So you have apa? You have 5 categories Okay, 5 categories. Ini. Your K is equals to 5. So 5 minus 1. Okay, 5 minus 1. Degree of freedom is 4 from your stats table. So 9.488. So since your chi-square is less than, fail to reject H0. So fail to reject H0. That means we accept our H0. We are able to reject the null hypothesis that the distribution of X is Poisson with mean 1.5. Okay. Ataupun you can conclude that there is evidence to indicate that the data follow a Poisson distribution with mean 1.5 since we fail to reject H0 at 5% significance level. Okay, so that is what we call as goodness of fit test. Okay, any question? Ada apa-apa soalan ke? Okay. Okay. Okay, itu part A Part A, sebab dia ada beberapa part ni. Okay. Part A, given 100 observation, you want to check whether Poisson with mean 1.5 is an appropriate model. So there is no parameter to be estimated. P is equals to 0 because your lambda is given. Okay. Second question, based on this 100 observation, again, is a Poisson distribution with mean 1.2. So now your lambda is 1.2. Perform a goodness fit procedure with alpha 0.05. Okay, ini kita tengok Perbezaannya, the difference is, okay, now, if we repeat, okay, same thing, lambda equals to 1.2 is given. So again, there is no parameter to be estimated. So P is equals to 0. So your degree of freedom is just K minus 1 Okay. So now, you have your observed frequency here, the same observed frequency. You again compute balik your probability. You can try on your own nanti. Compute back your probability with lambda equals to 1.2. So you get probability X equals to 0. The same thing, kita repeat. Yang last kali mesti 1 minus lah. Okay. Because the total up semua ni mesti 1 probability dia. Kalau tak dapat 1, make sure you double check balik you punya probability. Okay. Then we proceed. Compute EI. EI is just N times your probability. So 100 observation times your probability. So we check EI greater than 5 ke tidak. So this one, check your EI whether this one is greater or equals to 5 or not. Okay, the last category, your EI is less than 5 because we have 3.38. Okay, rule of thumb there, EI must be greater or equals to 5. So what happens when your EI is less than 5? So what we need to do is combine categories. Okay, combine to the nearest cell ataupun the nearest categories. So we need to combine your expected frequency, combine your observed frequency. Now you have 15 observation, 11 plus 4. Again, 8.67 plus 3.38. So dapat apa tu? Okay, so you have 12.05. Your new expected frequency. So new observed frequency is 15. New expected frequency is 12.05. We combine the categories with nearest value. Okay, since the last category EI is less than 5. Kita combine sampailah EI dia lebih besar daripada 5 lah. So kita stop lah. Let's say kita dah combine 1, kita dah dapat lebih besar daripada 5. So kita stop sampai situ je. Okay, so now, kita tengok So again, kita combine this one. So you have 15. Combine your expected frequency, you have this one. Okay. So now since we already combined the categories, so instead of 5 categories, now we only have 4. K is equals to 4. Okay, now the degree of freedom, K minus 1. So 4 minus 1. Your degree of freedom now is 3. Bukan lagi 4. Because we already combined the categories when your expected frequency is less than 5. So kita combine to the nearest cell ataupun nearest categories. Okay. So instead of 5, now you get 4. Okay, yang lain tu kita proceed benda yang sama lah. Okay, you find your chi-square, and then once you already find your chi-square, check lah, reject or fail to reject. So this one So again, data follow Poisson distribution with me 1.2, data does not follow. Okay, find your chi-square test. So reject when you have your chi-square alpha, degree of freedom 3. So this one is 7.815. So compare lah, since this one is greater than or less than, either you reject or fail to reject H naught, and then write the conclusion whether your data follow Poisson distribution with mean 1.2 or data does not follow with mean 1.2. Okay, itu basically when you have your EI less than 5. Okay, lambda is given, tapi EI dia, categories dia, EI dia less than 5, so combine categories, so your categories reduced by 1. Okay, so itu second case. Okay, first case macam biasa. Proceed macam biasa je. Okay, EI semua lebih besar pada 5, so proceed, compute your chi-square. And then lambda is given. You just find your probability. Okay, using your Poisson probabilities. Okay. Okay, chi-square 3.07 compare dengan 9.488. So fail to reject H naught. So what is your conclusion? So this one, lambda is given, but your EI is less than 5. Okay. Third case. Okay, third case. Based on this 100 observation, is a Poisson distribution and appropriate model perform a goodness of fit and alpha this one. Okay. So the last question, you would just want to test whether Poisson distribution is an appropriate model. So that's mean your lambda is not given. Okay, lambda is not given. Once lambda is not given, lambda is not given. When your lambda is not given, that's mean you need to estimate your parameter. Kita perlu estimate. Okay, lambda is not given. Okay, we need to estimate your parameter. Okay, estimate your parameter. Okay, what is the estimated value of your parameter lambda? What is your lambda ni? Jawapan dia ni. Macam mana kita nak dapatkan dia punya nilai lambda? What is your estimated parameter? Tahu tak macam mana nak kira dia punya estimated parameter lambda? Okay, lambda is your average. Average value. Kan, average ataupun the mean. Okay, so that's mean the same way we compute an average. Okay, you already have your values ataupun your outcome, and then you already have your observed frequency. So you want to estimate your lambda hit. Ini, lambda hit. So that's mean 0, okay, times 24, 1 times 30, 2 times 31. Sebab dia macam average average. 3 times 11, 4 times 4 divide by, you have 100 observation. Then you get lah 1.41. Okay, I assume jawapan dia betul. Okay, cuba kamu check. Okay, betul Okay, so 1.41. So that is the method how you want to estimate a new lambda. So dia akan jadi lambda hat lah ni. Parameter to be estimated, we only have one parameter. So why 1? Because this one is a Poisson distribution, we only have lambda. Okay, normally parameter to be estimated tu soalannya adalah Poisson lah. Because that one is much, yang paling simple lah nak compute Poisson distribution for lambda. Kalau kita ada normal, kita ada mu, kita ada sigma square. So kita ada dua parameter to be estimated. So normally when we want to test that normal distribution, we already set the question lah, mu berapa, sigma square berapa. So you don't have to estimate your parameter. Normally kalau Poisson, for certain question lah, you need to estimate what is your lambda if your lambda is not given. Okay, when lambda, we compute your lambda, which is 1.41. So now we only have one parameter to be estimated kan. So that's mean you have K, 5 categories, minus 1, minus 1. So degree of freedom 3. Given that your EI ni, kalau EI ni semua lebih besar pada 5, okay lah. Kita ada 5 categories. Okay, minus 1. One parameter to be estimated. Okay, minus 1. So you have 3. Katakan one of your EI is less than 5. Katakan ini less than 5. So that means still you kena combine lah. Combine dia punya observe, combine you punya expected frequency. Okay, bila kita dah combine, again, K dia akan jadi 4 lah. 4, one parameter to be estimated. So dia akan jadi 2 kat sini. Itu kena check lah, bergantung pada soalan. Katakan soalan ni, your EI pun less than 5, there is parameter to be estimated. So that's mean this is your degree of freedom lah. You have your K, dah reduce categories dah. Okay, minus 1 parameter to be estimated, minus 1. So you have to. Okay, kalau ini je, EI dia okay, semua lebih besar pada 5. So just your parameter to be estimated. So 5 minus 1, minus 1. Okay, itu perbezaan 3 case ni. Okay, 3 case yang telah stated kat sini lah. Okay, so setiap case tu berbeza-beza. Okay, you can try lah on your own for B and C. Okay, kita boleh cuba dapatkan probability dia, tengok. Okay, this one. Okay. Okay, bila kamu nak tulis yang macam tadi, so just write macam ni je. Data follow Poisson distribution, data does not follow Poisson distribution. So that's mean we know this one, you need to estimate parameter. Okay. Kalau kira ni, that's mean you need to estimate your parameter lambda. Okay. Okay, we go back to the module.